You see them in just about every work zone along our roads and highways. Officially, they're concrete safety-shaped barriers, or CSSBs. They've become an accepted traffic control device used by most state highway agencies and by more and more city and county agencies as well. Protection is the main function of barriers, the protection of motorists, pedestrians, and workers alike. While barriers may not reduce the frequency of accidents, they have reduced the severity of accidents involving construction activities that intrude into the traveled way, or involving motorists who intrude into work areas. Barriers may also be used to separate two-way traffic. And they may serve an additional function of channelizing traffic. However, this use should be determined by an engineering analysis of the protective requirements of the location, not the channelizing needs. But regardless of their usefulness, there is a problem with barriers. They're often hard to see. Despite their massive size, they tend to blend with the pavement and with their surroundings. This is especially true when the conditions and surroundings provide little contrast, or when rain, snow, dust, or fog hamper visibility. At night, it gets even worse. Concrete barriers can become a visual black hole. Most states, to increase barrier nighttime visibility, enhance barriers with a variety of channelizing and delineating devices. These devices mark the roadway's alignment and outline the course that vehicles must follow. Channelizing and delineating devices give drivers a line of discrete visual cues to guide them along a well-defined path through the work zone. This video program's aim is to improve roadway delineation practices at concrete barriers, principally at portable and quick-move barriers in construction and maintenance work zones. We'll look at the current standards for roadway delineation at barriers, two typical situations in which barriers are placed, some recommended delineation techniques, end treatment delineation, maintenance considerations, and finally, the factors that must be considered in the selection of delineation devices. So first, the standards. The existing national standards are found in the Federal Highway Administration's Manual on Uniform Traffic Control Devices, the MUTCD. Many state agencies have developed their own standards in addition, but in all cases, the state traffic control manuals must either substantially conform with the MUTCD minimum standards or exceed them. You should know your agency's requirements and follow them. As for the national standards, in Part 6 of the MUTCD, you'll find a definition and description of portable barriers. You'll also find references to the functions of barriers as protective devices, separators of two-way traffic, and channelizers. As protective devices, barriers are designed to keep vehicles from penetrating into areas behind them, to both minimize damage to impacting vehicles and their occupants, and to reduce the risk of injuries to pedestrians and workers. Barriers may also be used as separators of two-way traffic to reduce the potential for head-on collisions. In addition, barriers may serve as channelizers of traffic. However, the MUTCD points out that their use in this function should be based on an engineering analysis of the protective requirements of the location, not on the channelizing needs. When barriers are used as channelizing devices, they should have a light color for increased visibility. For nighttime use, the MUTCD requires that barriers be supplemented by the use of standard delineation or channelization markings or devices. Specifically, channelization markings are pavement edge lines, or lines supplemented with raised pavement markers, or lines simulated by closely spaced raised pavement markers. Channelization devices include tubes, cones, vertical panels, drums, barricades, and yellow warning lights. For nighttime use, the devices should have higher performance type retroreflective materials on them. Yellow warning lights may be installed to delineate concrete barriers. The first two may be Type A flashing lights, but all the rest must be Type C steady burn lights. The mounting height of warning lights should be about 38 to 40 inches, about the same height as when mounted on top of drums or barricades. The ends of barriers should be marked with object markers and treated in a crash-worthy manner to lessen the effects of impact in case vehicles hit them. Part 6 of the MUTCD also addresses roadside delineation. The retroreflective elements for delineating devices must have a minimum dimension of approximately 3 inches and should be about 4 feet above the near roadway edge. The standard color for devices used along the right side of roads must be white, while along the left side, the color must be yellow. In addition, Part 6 of the MUTCD addresses the minimum design and application standards for channelizing devices. Now, these devices vary in shape and size, but are always orange and white. Part 6 also addresses the design and application standards for warning lights. Now, that's pretty much it for the national standards. In the rest of this program, we're going to look at current practice and other recommendations and guidelines for roadway delineation to supplement portable barriers and improve their visibility. There are two main situations in which barriers are placed on the roadway, and these situations determine the devices to be used with them. Situation 1 is illustrated here, where traffic must be restricted to the travel lanes and where there's enough room between the barrier and the nearest open travel lane to place and maintain channelizing devices, then standard channelizing devices should be used. The MUTCD defines these channelizing devices as barricades, drums, vertical panels, cones, or tubular markers. So place and maintain channelizing devices wherever there's enough room, but do not place delineating devices on the barrier segments. To repeat, no devices on the barriers. The barriers still serve as protective devices, of course, but the channelizing devices define the travel path. In all cases, you also want to have a good edge line, one that's highly visible and of the proper color. The edge line may be a continuous line or a line supplemented by raised pavement markers, or a series of closely spaced pavement markers that simulate a line. Again, this is situation 1. Now, situation 2 is shown here, where there is little or no space between the barrier and the adjacent travel lane to place channelizing devices. The delineation or channelization can be made part of the barrier itself. Now, this is by far the more common of the two situations. Again, standard delineation calls for a good edge line, supplemented perhaps by raised pavement markers, and it calls for channelizing or delineating devices on the barrier segments. And that brings us to delineation techniques. Several devices are recommended based on the results of studies and field practice. Steady burn lights, vertical panels, and retroreflectors. But a word of warning, while these devices will enhance barrier visibility, they can become deadly projectiles upon vehicle impact. Or they can cut off body parts of passengers ejected from vehicles in a collision. The devices and mountings shown throughout this video were selected because they minimize this risk. Type C steady burn lights are low wattage battery powered lights with yellow lenses. They are mounted directly on the top surface of barriers. Steady burn lights work fine on tangent sections of barriers, and they're especially recommended for curves and transitions. They clearly outline the travel path well ahead of the vehicle, and they don't depend upon retroreflection from headlights for visibility. Vertical panels are another recommended form of delineation. These panels show direction and are retroreflective for good nighttime visibility. The standards require that the panels be 8 to 12 inches wide and a minimum of 24 inches high. Be sure that the panels are installed so that the stripes are angled downward in the direction that traffic is to pass. Like the steady burn lights, vertical panels are fine for delineating tangent sections. They may be supplemented with steady burn warning lights if used for channelization at night. This is especially the case where horizontal curves require good path definition. The decision to require the adding of warning lights should be based on an engineering study. Next up are retroreflectors. They include simple devices such as this small plate with retroreflective sheeting on it, to more sophisticated devices based on cube corner retroreflectance principles. As you see, these retroreflectors have a raised shape that's designed to reflect light better. Retroreflectors should be used only where there's a need to supplement standard channelizing and delineating devices. Now, so far, most of the channelizing and delineating devices you've seen in this video program have been positioned on or above the top surface of the barriers. But retroreflectors are sometimes side-mounted, positioned anywhere from just below the top of the barriers to all the way down at the base. The most popular position, however, seems to be from 5 to 16 inches down. Retroreflectors must conform with the color coding requirements, that is, yellow devices on the left side of the roadway and white devices on the right. Barrier end treatments and their delineation require special measures. The ends of barriers often pose a hazard to drivers. Good engineering practice requires that the danger be reduced by providing a crash-worthy end treatment. Details on appropriate treatments are discussed in the AASHTO Roadside Design Guide. A Type 3 object marker should be mounted at the approach end of the treatment. The marker should have approximately the same width as the treatment and should be mounted 1 foot above the ground. Drums or other proper channelizing devices should be used to channelize vehicles up to and past the barrier end segments to tie into the rest of the barrier installation. Where channelizing devices are used, the barrier end segments must not have any delineating devices placed on them. Delineating devices would only cause confusion. Where channelizing devices cannot be used due to space limitations, the end segments must be delineated. The MUTCD allows the use of yellow warning lights, but only the first 2 may be the Type A flashing kind. The rest of the lights must be Type C steady burning. Now, to point out some other delineation techniques and guidelines. In some states, top-mounted devices are supplemented with side-mounted ones on the same barriers, or they are alternated from barrier to barrier. The purpose is to increase nighttime visibility and to keep glare and dirt from making the devices ineffective. In some states, another delineation technique is to paint all the barrier segments with white pigment. The paint can be made more visible at night by adding glass beads. Other techniques call for painting only the approach segments, either all white or with diagonal orange and white stripes. Barriers can also be made more visible if white cement or white aggregates are used in their manufacture. Another factor in making devices effective is spacing. The spacing greatly influences how well motorists will see the devices and follow the path they define. Typically, on curves and tapers, you should space devices at an interval in feet that's equal to the speed limit in miles per hour. For example, for a 40 mile per hour speed limit, the devices should be spaced 40 feet apart. On tangents, the interval can be twice the speed limit. For example, at 40 miles an hour, the devices may be spaced 80 feet apart. A barrier on the outside of horizontal curves is more visible than a barrier on the inside. Here, for example, the barrier is easier to see because it's on the outside of the curve, and therefore the delineation is more visible. So when the barrier follows the inside of a curve, you should space the devices closer to increase their visibility. The rule is, the smaller the radius of the curve, the greater the need to reduce the spacing of devices. Many work zones have another problem: glare from the headlights of opposing traffic. Drivers have trouble seeing the delineation while looking toward the blinding lights. One solution to the problem is a glare screen. With retroreflective material attached at intervals to individual blades, the glare screen both blocks the opposing headlights and delineates the roadway. The maintenance of delineation and channelization devices is critical. Think of it in terms of 3 activities: routine maintenance, replacement due to damage, and cleaning. As part of routine maintenance, highway agencies should make frequent night reviews to determine the effectiveness of traffic control devices in work zones. Be sure to service the warning lights. Through time, their batteries become weak and their lamps burn out. You can replace lamps and batteries according to a schedule or on an as-needed basis, but always be sure to replace any burnt-out lights promptly to avoid gaps in the delineation or channelization. Routine maintenance also applies to devices that have lost their retroreflectivity because of constant exposure to the effects of heat, cold, wind, moisture, dust, de-icing chemicals, and vehicle emissions. You should replace such worn-out and faded devices when they no longer function properly. As for replacement due to damage, first, there's never a shortage of accidental damage. When devices are struck by construction equipment, traffic, or other objects. And there's intentional damage as well. Both the theft of devices and vandalism can take a serious toll, especially in high-density residential areas. The replacement of devices at such locations may become a regular task. The third maintenance activity is cleaning. Although it should be obvious that the devices and markings need to be cleaned frequently, field practice tends to neglect this duty. And that's a serious problem, because the same grime that eventually damages devices and markings causes more immediate problems by reducing their visibility. While all devices get dirty, studies show that dirt accumulation on channelization and delineation devices increases as the mounting height decreases. So side-mounted supplemental devices need more frequent cleaning than top-mounted ones. Nevertheless, you should routinely and thoroughly clean all devices to allow them to be seen by motorists. And while you're cleaning them, inspect them for damage and replace them as necessary. The selection of channelizing and delineating devices by government agencies and private contractors should be based on several key factors. If you're among the decision makers, you ought to first consider those devices that meet the national standards and their overall effectiveness. How well do they delineate barriers and define the path? Well, this is basically a function of how visible they are. And visibility is affected by a number of things, including size. The current MUTCD standard allows the use of devices with a minimum dimension of approximately 3 inches. But you should consider using devices with larger retroreflective areas, say 24 square inches as a minimum. Research shows that larger devices are more effective than smaller ones. More effective, yes, but not necessarily more cost-effective. And cost is a legitimate concern with all devices. Besides the variations in purchase price, there are variations in the costs of installation and maintenance. For example, These modular assemblies of glare blades are much easier and less costly to install than are the individual blades that must be anchored in place one at a time. However, the cost of modular assemblies is much greater than individual channelizing or delineating devices set at the appropriate spacing. Another example of cost consideration concerns Type C steady burn warning lights. While they receive high praise for their effectiveness, their higher installation and maintenance costs have stimulated greater interest in passive retroreflective devices. The maintenance factor in device selection is also evident in the issue of top-mounted versus side-mounted devices. There appears to be a strong preference for top-mounted devices because side-mounted ones require more servicing and are harder to get at. The side-mounted devices should be used only to supplement standard channelizing and delineating devices. Another maintenance point that might affect device selection concerns cube corner type devices. Compared to other devices, they lose less retroreflectance because of dirt accumulated through long-term exposure. And one final point about selecting devices and markings. In urban areas, portable barriers are often used to protect pedestrians. But because streetlights and other illumination help us to see the barrier segments, some city officials wrongly conclude that there's no need to improve their visibility with standard devices. However, the MUTCD requirements apply equally to urban as well as rural situations. Actually, urban conditions call for increased attention to adequate visibility and delineation. Deployments of short sections of barriers are common because of intersections, driveways, bus stops, and crosswalks. With so many shifting traffic patterns and narrow traffic lanes, drivers need all the path definition they can get, and pedestrians need to be protected. One thing is clear, there's certainly a variety of channelizing and delineating devices and placement methods in use around the country, a result both of past and ongoing research and of trial and error practice. In summary, we recommend that you follow all national and local standards in providing effective barrier delineation through work zones, that you select and use the types of devices that will provide the best delineation, that you employ proper techniques in placing devices, and that you inspect and maintain the devices to ensure continued service and safety. Clearly, highway construction and maintenance work are always with us, and portable concrete safety-shaped barriers are here to stay. Barriers do their job of protecting motorists, pedestrians, and workers. But to be visible in all conditions, they must be delineated with effective devices that are correctly installed and properly maintained. By delineating barriers effectively, we promote safe travel through our work zones along the well-defined path.